Okay, so to start our warm-up today, if you read the directions, you say determine if each function has a maximum or a minimum value, then find it. So did this ask me to graph it? No. Did it ask me for the axis of symmetry or the y-intercept or the domain and range or any of that stuff that our homework talked about? No, all I need is a max or a min. So all you need to do is type this in a Desmos, and you need to then tell me, is there a maximum point, a highest point, or is there a minimum, a lowest point? This one has a max? Okay, can you tell me what that max is? Anybody have any issues there? Nope. Okay, go on to the next one, please. Can you type this in a Desmos, please, so you can look at it? Folks, what is f of x the same as? So if you didn't want to type in f of x, you could certainly put that in as y, but Desmos will take f of x. Okay? Okay, so what do we get, a max or a min? A min? What is the min? Is it okay that those are decimals? Yeah, I mean, it kind of stinks to have decimals, but it's okay that they are. Okay. Derek, you okay back there? Okay. This one has a min. And okay, so I need to know right now if anybody has any questions with how I got this or how to type into Desmos or what we're looking at. Speak now, please. Say that again. Correct. We're all good here. So if I ask you to do this right now, another one, you could do this for me. Okay? All right. Yesterday, we talked about filling in this chart, how we have 3 types of functions. Can you tell me what a linear function looks like? And on a graph, that will be a line. Good. What does the M stand for? Slope. And the B? Okay. Where do we start on these graphs? Okay, so this is the start. Good. A line is not curved. Somebody tell me why it is not curved. Why is it in fact straight when I graph it? Yeah, the slope stays the same every time, doesn't it? If I start changing my slope, then my line gets all jacked up. Agreed? Okay. So when it is linear, we have consistent change. If it starts out going up 1 over 4, it stays going up 1 over 4. It doesn't change halfway through. It is consistent. Okay, so that is what we talked about for a linear equation. Then we also talked about an exponential equation. What does an exponential equation look like? Okay, BA to the power of x. What does the B stand for? The starting amount? Okay. What does the A stand for? Okay. And just remind me, what do all percents start out as? 100, and then we go from there. Okay, what is the indication that an exponential function needs to be used? This over here was consistent change all the time, correct? What does an exponential always have? It could be double, it could be triple, and it could be half. But those were the special ones that didn't have the symbol. Correct. These are normally a percent of change. Those 3 that you just gave me were the special ones that don't technically have a percentage, but they mean a percentage. Everybody doing all right? What word does exponential have in it? Exponent. What happens when I raise a number to an exponent? Okay, and what happens to it? it gets like really big. You guys agree that as soon as I start doing exponents, it gets super, super big? So it goes up really fast. So on a graph, it would look like that. But what if it was depreciating? Then it goes down really fast. So basically it would look like this. Okay, wonderful. And then yesterday, we introduced what a quadratic equation was. Now, I'm not quite sure if we hammered this home yesterday, but quadratic means a power of 2. Do you agree that this quadratic equation over here has a highest power of 2? Yes. What is this form called again from yesterday? No, what form is it? You know how this linear equation that's called slope-intercept form? What is this form called? It was at the very top of your notes. No. It was called standard form from yesterday. Okay. This is standard form. Okay. In standard form, you guys all see that little parentheses over there? What does that V stand for? Vertex. If you're going to find your vertex, you're going to do negative B over 2A. Okay. That's to find your vertex. And again, this is in standard form. Today, we're going to introduce something called vertex form. Do you see the word vertex form at the top of your page today? Do you see it in all caps and underlined? Okay. Vertex form looks a little bit complicated, but it's actually easier. Okay. This is vertex form. The indication that you see vertex form is if there's parentheses in it. Standard form does not have parentheses, but vertex form does. Do you all see how it's a major difference from one to the other? What's that? It is a K, yes. Now, to find the vertex in vertex form, we do H comma K. Now, folks, if you look at vertex form, do you see the H and the K in vertex form? That's the H and that's the K, correct? Now, does everybody see how this H is negative, but this H is positive? So do you agree those are opposites of each other? Do you agree that this K is the same as this K? Okay, so those are going to be the key things for today. What shape is a quadratic equation when it's graphed? What shapes do we make on all those graphs? A U shape, which is called a parabola. It could be face up, like that, or it could be face down, like this. I'm going to put something in there. If you're going to use a quadratic equation, it's because you need to show a maximum or a minimum. Isn't that one of the questions I asked you every time yesterday? Does it have a max or a min? And that's exactly what we started in our warm-up today. Okay. So to answer your question here, Derek, I had to put in these 2 boxes so I could get that box on that one. I don't need anything in these 2 over here. Okay. All right, folks. So I think I'm ready to introduce to you vertex form. Yes? We good? Okay. So here we go. Oh, wait. I forgot domain and range. What's domain? All x's. What's the range? All y's. Good. Yeah, we talked about that yesterday as well. Sorry, I almost skipped right over it. Ooh. Google will do for you, right? Wait, say that again. All possible values of the independent, what did it say? Independent variable? Yeah, I think you guys probably talk about this in science class. Independent and dependent. Independent is always the input, what you put in first. Isn't that always x? Don't we always go to the x value first and then the y value? So these would be all the dependent variables. So it just should all make sense to you. All right, so here we go. First things first. Do you see how the directions are identical to yesterday? I am finding all the same things. Okay, and just like yesterday, please cross off this table of values because what are we using to graph these? We are using Desmos, thank goodness. Okay, we are using Desmos. All right, do you agree, or disagree for that matter, that this equation up here has parentheses in it? And that parentheses is squared. Therefore, this looks like vertex form. Do you agree that this thing looks like that up there, just with numbers in it? So here's what I want you to do. I would like for you to, underneath there, I would like you to write vertex form right underneath there so we can see all those numbers lined up. Okay. In vertex form, the vertex is H comma K. What is in the H spot up there? 2 is, correct? But remember, this H is negative and that H is positive, so they're opposites, correct? So what's the opposite of 2? So that is my X value. Now, because it's a plus 2 right there, do you see how this H is negative but that H is positive? So they have to be opposites of each other. Kind of, sure. And then folks, does everybody see the K over here? What's my K? 2. Now the K's are just the same, aren't they? So it's just a 2 over here. So that looks like it should be my vertex. We're going to get on Desmos and we're going to check and make sure. You already did? It is. Wonderful. So let me go ahead and type mine in, please. Can I get somebody to read that off to me? Okay, I'm going to use y equals. Go ahead. Whoops. Okay. Squared. Okay. All right. Does anybody have any issues typing this in to their graphing calculator app? Okay. See this guy right here? That's a squaring it. Now, Dalton, if you want anything besides squaring it, you would use this one over here. Does that make sense? Did it work okay for you? All right. We're okay now with this? Is this a parabola? Because it's a U shape, correct? Did we get our vertex correct? Perfect. Do you see the line that would cut this parabola straight in half? Does that line go through the vertex? Yes, it does. Is that line vertical? Yes, it is. So when I come back here and I ask you for letter B, which is the axis of symmetry, what are you going to tell me? Listen, the axis of symmetry is vertical, correct? Which means it never crosses which axis? The y, which means it has to start with an x, correct? Yes? Now, guys, I want to make sure we understand this. Does the axis of symmetry go straight through the vertex? It does. So it has to have the same x value as the vertex. What is the x value on the vertex? -2. Are we all crystal clear on this? Okay, let's put it on your graph. -2, 2 is right here. And then the axis of symmetry goes right through it. That is my mirror. That is the line that cuts it straight in half. Next question. Is there a max or a min? Everybody is in agreement that this thing has a minimum point, a lowest point. So we're going to write a min in here. Okay, now we're going to talk about domain. We just said that domain was all the x's, correct? X's go left and right, agreed? As this thing keeps going, it gets wider and wider and wider and wider and wider, correct? Okay, so eventually my parabola can go all the way down to Mr. Overmeyer's room, and eventually it could go all the way down to Mrs. Fox's room, because I can make it as wide as I possibly want. Agreed? So what does that make the domain? All real numbers for my domain. Okay, so for letter D, domain is going to be all real numbers. Remember, I use that funny looking R if I don't want to write it out. Range is the y's. Y's go up and down, don't they? This thing keeps going up and up and up and up because it has a minimum point, doesn't it? If it has a minimum, are all the y's greater than it or less than it? Greater than it. Greater than whatever the y is right there. What is the y right there? 2. So for my range, the y is going to be greater than or equal to 2. Now look at Desmos, and there should be a little gray dot on your y-intercept. Where does this parabola cross the y-axis? 0, 6. Now, folks, if I know 0, 6, and I know this thing is symmetrical, I know there's another point 2 units away from the axis of symmetry. Yep, you got it. How we doing there? Is that okay? Okay. Now, this was the trick that the tip, I shouldn't say a trick, a tip that I wanted to give you. I need to find one more point because right now this thing looks like a V, doesn't it? I need to make it look like a U. You want to try and find a point that is relatively close to your vertex. So when you're scrolling on your curve, look very close to your vertex. -1, 3, which would be right here. And then -3, 3 would be the mirror image. Perfect. Now does it look more like a U? It does. So now we'll connect our dots, and that is my parabola. Everybody all right? Now, we all know that this thing can either be face up or face down. Agreed? There's a way to tell without even graphing it. If it starts with a negative, it's going to be face down. Do you see how this started as a positive up here? So it's going to be face up. And I'm going to go back and I'm going to show you on our examples from yesterday what that looks like. Oh no. Oh, there we go. This one right here. We had to rewrite it because it was not in the correct order. Agreed? Okay, I'm up here, guys. Does it start with a negative? Which means it's down. Does everybody see how that's down? How about this one? Start with a negative or a positive? Oh, so it is down. You see how that's a correlation there? How about this one? Does it start with a negative or a positive? So it is face up. Wonderful. Okay, I'm ready to go to the back and try another one. Do you agree that this is vertex form? Because it's got parentheses and it's squared. Okay, so vertex form, I'm going to write right up above it. Looks like that. To find the vertex, that's the most important point, we're doing h comma k. What is the h in this problem? Right now it's +5, but I need to make it -5. How we doing? And then what's the k? So I'm hoping that this is my vertex. Can you verify for me by typing it in? Okay, go ahead. Everybody type it in. We're going to need it anyways to find ourselves some more points. When you're ready, when you have verified that, go ahead and put -5, -3 on your graph. I want to make sure nobody has any issues typing this in. Everybody doing okay? Now, from looking at this, does this thing start with a negative? Does this equation start with a negative? It does, so this should be down. Does it look face down? Like a hump instead of a valley, right? Like a hill instead of a... Okay. Anybody having any issues here? Here's where I can come help if I need to. Okay? Dalton, how you doing over there? Good? Okay, now that axis of symmetry cuts it right down the middle, right? Go ahead and draw that in there, please. One year I had a student thought that I meant that we were going to draw right on your Chromebook. So I was like, no. Please don't do that. There's my axis of symmetry. What is the equation of that line? Remember, x is what the x value is. That's always the first value in your order pair. Okay, does this thing have a max or a min? It has a very highest point. What is the domain? I can make it as wide as I want. It's going to go down, and it's going to keep getting wider. Okay, so here's where some logic comes into play. If this thing has a maximum, are all the y's going to be greater than it or less than it? Less than or equal to, that's at the vertex, right? The highest points at the vertex. So the y value at the vertex is -3. Good. Now, look at your Desmos and tell me where this thing crosses the y-axis. Yes, it does. You might have to scroll to find it. No, it crosses the -53. You have to really scroll, but it's down there, right? You might have to zoom out and scroll down to see where it crosses the y-axis. Does anybody need help doing that? Now, can I graph that on my paper? No way. I go down to -10. There's no way I can put -53 on there. So unfortunately, I can't use that as another point. Can you go back to where your vertex is and look around your vertex to see if you can find another point for me? So in Desmos, right here, you're going to look around this. Oh, I don't even have my right equation in here. Hold on a second, guys. Y equals, is it -2 times x? Okay, so here we go. Did somebody find one for me? So, Dalton, I know you weren't here yesterday, so I'm just scrolling to find myself a nice point, and it looks like right there-ish, right there, will be -4, -5. So I'm going to come back here and put -4, -5, and then I'm going to do the mirror image on the other side of it. Did you find me another one? Gonna have to go down a little bit, I think. -3, -11. Now, I know it's not on my graph, but it's pretty close, right? So I'm going to improvise here and say that that's -11. What's wrong, Derek? Is that not right? Everybody doing all right? Yes or no? We're okay improvising. Okay, so then the mirror image of this point would be over here. And again, this looks more like a U now. Do you guys see how this U is a little thinner? Yeah, there's a reason for that, and we'll learn about that next week. It's a little bit skinnier, isn't it? Mm-hmm. Yep. Okay, how we doing? Try again. Okay. Take a look for me at number 3. Do you agree or disagree that this is in vertex form? I have parentheses and it's squared, so I'm going to go ahead and write vertex form up above it. Uh-oh. What am I missing? Not the A, because the A would be -1. I'm not missing the H. The H is right there. The K, do you see how there's no plus something on the end? So what can I put on there that would not change the problem? +0 will go on there. So now that I've got all that straightened out, let's find my vertex, which is supposed to be H comma K. What's the H in this problem? But then for the vertex, I have to do the opposite of it, which will be +3. And then what was the K? 0. So let's go ahead and type it in. Hopefully we will confirm that 3, 0 is in fact my vertex. And then you could go ahead and draw your axis of symmetry right down the middle. Cut it straight in half. Strong. Okay. Guys, an axis of symmetry will always be vertical. Can you tell me the equation of that axis of symmetry? X equals the 3. Remember, it goes through the vertex, folks. So it has to have the same x value as the vertex. All right, does this thing have a max or a min? A max. What's the domain? What's the range? No, the less than or equal to what? 0. Wonderful. And how about a y-intercept for me? Ooh, that'll fit. Right? Won't that fit? So put it on there. What's that? Wonderful. Let me make this mirror image over here. And then I'm ready when you are. 2, -1. Like that. And it looks like a U, doesn't it? Okay. What's wrong, Dylan? Hey, come on. Oh, we are right here? We get the last one done? Yeah. Now, I already know you probably don't like the last one because it's got a fraction in it. But you don't have to do any calculating in vertex form. You literally are just plucking the numbers right out of vertex form. Go ahead and write your vertex form. Can I ask you if this thing is face up or face down? Because it starts with a positive. Okay, so now that I have my vertex form in here, I'm looking for h comma k. What is the original h? 4. So then what is the h in my vertex? -4. And what's the k? 3. Okay, graph it. Let's confirm. You either put in f of x or you put in y. Yep, you put a division bar, and it should make it into a fraction for you. And then you have to press over to get out of the fraction. Okay, make sure you hit that over arrow so you can get out of the denominator of that fraction. Are we confirming that that is in fact our vertex? Okay, so let's go ahead and put our axis of symmetry right down the middle. The line that cuts it in half. What is the equation of that axis of symmetry? Wonderful. And does this thing have a max or a min? It has a minimum point because it is opening face up. How about a domain? No, domain. Okay, now give me the range. Wonderful. Y is greater than or equal to 3. If we have a minimum point, all of the y's have to be greater than it. Always, yes. Always. For parabolas. Can you tell me the y-intercept? 0, 7. Oh, that's good. That'll fit. 0, 7 is up here. Oh boy, how far away from the axis of symmetry am I? 4. So 1, 2, 3, 4. Say it again. That's the mirror image, yes. -2, 4 is my another point. Oh, what is happening over there? Mr. Kamaleski's room. Does it look like a U? This U is a little wider than we're used to. And I will show you why that is later. Okay. It's a little wider than what we have typically graphed. Okay, so now you know the difference between vertex form and standard form. Which one do you feel is easier? Yeah, because in standard form, you have to calculate -b over 2a, don't you? Whereas in standard form, all you do is take the numbers right out of the problem. Good? Okay, I got a worksheet for homework, and that'll be it. Okay, so this is going to look very similar to the worksheet that you had yesterday. Okay, except for now, they are in vertex form instead of standard form. Yeah, guys, do we need to use the tables? No. We don't. Did you turn in homework today, sir? turn in your homework tomorrow?
Yes, I will.
Listen, if you don't turn it all in tomorrow, I'm writing you up to make these after school.